Welcome back. In the last set of computer videos, we took a look at all the hardware, both old and new, and one of the things I mentioned was a new upgrade for this hard drive. Now this particular drive is a Kingston HyperX 3K. This is a 2.5 inch drive, and it's just, your standard SSD. This one's a SATA 3, and it's got a read speed of 555 megabytes a second and a write speed of 510 megabytes a second, according to the manufacturer. The new drive, which is this one here, uses the M.2 connection, and this is a PCI-E interface instead of a SATA 3 connection, which is inherently faster. But this particular drive actually has a speed of, I think, 2.2 megabytes a second, and read speed of that, and a write speed of 900 megabytes a second. So it's substantially much faster, and it's going to be neat to put this in. It's my first experience with this. I did actually intend to do an unboxing video where I cut it open and everything, but unfortunately the audio didn't come out so well, and I realized that in the middle of it. So I'll just show you this now. I already had looked at it initially, but it is kind of cool. It's just a small card. Now they call this a 2280, so it's 22 millimeters by 80. There's a little connection, a half moon connection back here for a screw to hold it into place, and it just kind of fits in over here. And yeah, this is 256 gigabytes, and it's pretty quick connection. Now this is a VNAND SSD, and this particular one here with this M.2 connector has the NVMe interface, which this board does support, so we should be able to hook it up no problem. And this is actually going to go right below this video card here. I have to get the camera a little closer, but it goes in just below here. And if you just look at the size difference between that and this, I'll actually take it out of the packaging here just to show you how remarkably small it is. I mean, it's a really cool board. Yeah, it's tiny. And usually you'd have a PCI-E card that this goes into, and then you would insert that, but since this board has that directly on it, it wouldn't be a problem. So before I get too ahead of myself though, I'm actually going to pitch the camera up here, and right now the camera's, the monitor's displaying my server, but we're going to switch over to the output of this computer here, and we're actually going to do a speed test on this SSD currently, so we have a base to compare it to later. And using Crystal Disk Mark, you can see we have a pretty good read speed of 496, but a write speed of only 151. I'm not sure what that's all about, but definitely nowhere near what they're advertising. So we'll get a look at this later on. I'm actually going to take a screenshot of this here, and we'll save that for later use. Now it seems like they have some Magician software, I think it's called, that we can use to clone the current drive over, but of course we have to install it first. So I'm going to go ahead and pan this camera down and get you a better look inside. Of course, if you're curious, I ran the numbers for the internal Western Digital 1 terabyte hard drive as well, and you can definitely see that compared to the numbers from the SSD. The SSD clearly wins. Now let's take a look at the newer one. Alright, so our hard drive cage is here. Usually the SSD is on top of it, but anyway, we have the data here, your RAM, processor, and then the video card, and then right below here you can see the header for the actual M.2 connection, and that's here. And then there's a screw hole here, one here, and then the last one, which actually has a post in it with the screw on top, and that's to adjust for the different lengths that you can put in here, because after all, this is PCI-E, and I believe you can use it for other things besides SSD, and maybe in this particular format you can't, but Usually you can, but anyway, you would just move that post, have the appropriate sized screwdriver here to get the screw out, and then the RAM is, the stick I should say, is just going to slit in that spot there. So let me go remove that screw. And the way this goes in is very simple. You just slip the ends over here, and you'll see that they go in just like that. And then you just push the end down. It's got a slight spring to it, but you're going to want to push the end down and line up that screw hole just at the end there. And it's not just it's not a hole necessarily, it's just an actual like half moon, but we'll get in there. Of course my hand will block the shot, but I'll go in there and tighten that screw down. Now I did mention it in the last video, and I didn't mention it in the beginning of this one, but you should have your anti-static measures like a wrist strap, or well, you know, there's a lot of things you can do to be anti-static, and I did mention that in the other videos. But you can either touch out the bare metal, which there isn't really in this case. You could touch over here, I guess that's kind of bare metal, but you want a, you know, large body of metal to ground yourself out on. Bare feet on a bare floor works, that's what I usually do. Wrist strap. I'm on an anti-static mount underneath there. You know, there's a couple different things. Just don't shuffle around. But anyway, if I zoom in down here, you can see it just sitting nicely on the motherboard. It's really nice, close connection. There's no wiring. There's no power wires, cables, data cables. It's all included on this one little piece here through that header. And you can see it's actually just kind of just as long as the PCI-E X16 header that the video card's plugged into. So with a newer video card, this thing's going to rock and roll once I get that thing installed in it. But right now I'm going to boot into BIOS to see if we read this, and then before I shut the machine down, I actually installed the Magician software. Now that's going to be more for doing a diagnosis, and it does look like to be a benchmark program on there and whatnot. And we'll take a look at that benchmark, see if we get different results. And also I downloaded the data migration tool, which is exactly what it was called, and that's exactly what it does. It'll migrate the data over from the SSD old to the SSD new. And while I have one spot in my view over here, this is the USB 3.0 connector. I actually noticed that they have USB 3.0 card readers, so you should be able to get a little bit better read speeds on some of these higher speed memory cards. So that might be something I want to do to upgrade this case to, in at least this current configuration, until I get the new case to actually fit the large cooler that I bought that won't fit in this one. Anyway, let's get into BIOS. Okay, in BIOS, you'll notice a couple different things. First of all, it says SATA information, and M.2 is not available, which is fine because this is not a SATA M.2, it's a PCI-E M.2. So there should be another spot where we can find that. If I go down to boot menu here, you can see there are only two devices here, the CD-ROM drive and my current SSD. The hard drive isn't listed on here because it doesn't have any boot materials on it basically. But if I do go in the boot menu, you can see it does list it here as the Western Digital 1 terabyte drive basically. But the last one here, you can see this N1 Samsung SSD 950 Pro 256 gigabyte. That's our new SSD. If I click this, it'll automatically boot to that device. Since there's nothing on it, we're not going to do that right now. But we need to get this computer to actually have this come up at the top here. So we're going to have to play around in BIOS here and try to figure out how to do that. Now, what I figured out is if we go into advanced mode, and if I go over to, again, advanced, there's the different options we can play with, like PCH storage, and this is where you can set up the RAID configuration. You can also set up the PCI-E NAND configuration. That's set to auto, so I'll just leave that. And we go down to the bottom here where we saw M.2 before, and M.2 is empty. So it's kind of weird how it's popping up in some places but not in others, but maybe I suspect it has something to do with this being set to RAID. Not entirely sure yet. This is, like I said, my first time working with this kind of a device. But anyway, if I do go into boot, we can see it does give you two options, which are the ones we saw up in the front. But we can also go into hard drive properties over here, and we can actually see the last ones that Samsung. So we can actually go up to the top here and replace that. So I want to go see if actually Windows has that drive listed in there. So I'm going to actually exit out of here and boot right into Windows. And we'll see what happens when we get into the desktop. Now when you first get into Windows, you may want to initially go into Explorer here and take a look to see if the drive is listed, but it won't be because you have to actually initialize the drive. Which you normally go to My Computer over here on the side. You would right click and go to Manage, and then once you go into Manage, you'd go to Storage, and then go to, or on the side over here where it says Storage, go to Disk Management. And once Disk Management opens, you'll see all the drives listed. And down here you can see, well, disk 0 is the main SSD, disk 1 would be the D drive, disk 2 is 238.47 gigabytes and it's unallocated space. That is our new SSD. Unfortunately, the first time I came in here, this didn't appear, and I said, huh, that's kind of strange. I wonder if there's something else I have to do. After all, it wasn't like completely being shown in BIOS. And it turns out there's actually a driver for that NVMe system that you have to install, and you can get that directly from Samsung's website. And that's also where you download the Samsung Magician software as well as the data migration. So I managed to install those pieces of software and definitely the driver. First, obviously the driver, so you can make sure the driver does read. And the minute I installed that and restarted the system, it came right up in here. So now to actually get this to be allocatable, you have to right click on here and go to New Simple Volume and just walk right through this little wizard here. And this is just going to ask you some simple questions. So if you want to pause it and read what it says, but we're just going to click Next. And this is where you're going to adjust the actual size, and we're going to leave that as is. I just want one partition on there. You hit Next, it'll ask you to assign a drive letter. If you want to put it into a folder and don't do anything, we'll just leave the default drive letter, and you could switch this if you'd like, but I'll leave it at H. And we'll hit Next, and then it's going to ask you for what file system and the allocation unit size. I always leave this at default, unless you really knew which size of the table you're going to set it to, but I'll just let the system figure that out. And we'll leave it at the NTFS format, and I'll just leave again new volume. If I want, I can name this SSD. We'll name it Samsung Pro. $950. And we'll just do a quick format. I'll leave file compression off. Some people say you can do that with SSDs. I'll just leave it as is. I'm not really worried about it. We'll just hit Next and just confirm all the settings and hit Finish. And you can see this will format in no time. In fact, it's done already. And we should be able to go in here and open the file and see that there is nothing there. So how fast does this thing perform, you're probably wondering. Well, when you first saw this, we looked at the original hard drive and I saved the settings for that. And it's 496.1 on the read and 151 on the write. Let me just shrink this down, and I actually did the hard drive just to show what that actually was. And you can see the hard drive on the left, SSD on the right, so definitely the SSD current wins over the hard drive, for no doubt. For just looking at numbers, you don't even really need to know exactly what each number means. Obviously, it's sequential read and write speeds and 4K speeds. Just the jump in number. To do the same amount of data transfer for both tests, you have those. Obviously, that's your results, but there's that much of a jump. I mean, what's down here from 1 to 106, from 131 to 477, like that's amazing jumps, right? So let's see what the new SSD looks like. So we'll open up a live version here. I'll just put this over here so we can compare. And it said it can go up to 2500. I'm not anticipating that high of a number because, like I said, there's other bottlenecks that you're going to reach first before you get to the maximum theoretical speed. But it's definitely going to be faster than what I have. Be pretty upset if it wasn't. I mean, if anything, it's double the size space, so that's definitely good. I can definitely put more programs on here. Oh, actually, let me stop this test because I'm actually got the wrong drive picked. I got the hard drive D. I didn't check that before I started here. Yeah, because I was going to say 127. That'd be horrible. All right, let's see. Drive H. That's a lot better. Let's try that. Sorry about that. I should have checked it first. So yeah, I'm not expecting the high number still, but 854 versus 496. Yeah, so that's a huge increase. Much better than I was anticipating. Of course, it would have been nice to see the 2500. Now, I was just briefly playing along in the other program, that Samsung Magician, just to see what it did, and it's a drive health program, but it does also have a benchmarking section. So we'll actually have to take a look at that benchmarking section in there and see what numbers they provide. Maybe theirs is a little more skewed because they'll you know, just know it's a Samsung drive and they'll bump their own numbers up. That's possible. Or the tests that they'll run can actually handle this type of memory better, and you'll get a better result by default. But let me pause the film here and let this run its course. And taking a look at the final result, we can see the hard drive, the current SSD, and the new NVMe standard SSD, and it's a pretty good difference here. A couple things going for these. First of all, these two are SATA 3 drives, so they have a theoretical speed of up to 6 gigabytes a second, whereas this connection, I believe, goes up to 10 gigabytes a second, and that's the PCI-E connection, of course, and that's an X4 connection. Of course, that's also generation 3, so that's 3.0. But, you know, again, we're talking the spinning platter running at 7,200 RPMs versus solid state drives, so of course there's no comparison, but this alone just goes to prove that a basic SSD would totally increase the speed of any system. So if you don't have one of these and you've always thought of getting one, I mean, after all, it is 2016, they are becoming more commonplace, but if you do have an older computer with a spinning platter, you may want to consider upgrading that drive. And most of the drives have access to some kind of cloning software to copy the contents over to your new drive, so you can just, you know, swap your drive out currently. And in most situations, especially if you have a desktop computer, you can use the old larger hard drive as a you know, data drive, like I'm doing in this particular situation. In fact, if I wanted to leave all these in here, I could probably put all my programs and really intensive stuff on here. I could probably put some of my lower grade programs, video games, maybe some data that I would like to record a lot on here, and then save this for the remaining data. And you know, the only reason why you're doing this is because you want to avoid writing to that SSD too much, because you don't want to, you know, shorten the life of it. Even though the life is a long way, I think this is like 40 gigabytes a day that you can write to it before you'll shorten the life out. And I don't know how long of a lifetime, you know, how long you have to do that for, but they only have a limited number of writes. That's the gist of the conversation. So if you can avoid too many writes on that card, you're going to want to do that. So doing something like I said, putting your programs on here, or like I do the video editing, and I'm always dumping my camera out, and then when I'm done with the stuff, it goes on another hard drive. That data being written back and forth, it's probably better just to leave that on the hard drive, and maybe make like the actual program install on the SSD, and have the you know, the temporary RAM file as it is, have that installed maybe on a RAM disk, or have it installed on one of these other SSDs or something like that. But anyway, what I'm going to do now is I'm going to shut all these windows down. I'm going to open up the Magician software so we can take a look and see what that does, and then we're going to clone the hard drive over. And here we see when this opens up, the first thing it selects is its actual own drive, which is nice. We can go into smart reporting here, and it'll do the smart test, which is a standard test, and it gives you the different attributes. Now, the smart testing now allows for SSDs, it seems, because it actually tells you percent used and you know, some different numbers here that you'll need to know, like data units written and how many read. It's like a cumulative total, which is nice. Whereas spinning hard drives, they have sector errors. It's a different type of thing. I'll show you that when we get to the hard drive. But you can also take a look at, it tells you the drive health status is good, and of course that's in green, and then also has the total bytes written, so it shows you how much was actually wrote to that drive over time. And you also see down here its controller. This is the Samsung NVMe controller. This is the driver that I actually had to install to get this to work. And this actually tells you here, this is pretty cool, the PCI-E slot. Okay, so it's saying the link speed is currently 4 gigabytes per second with a maximum of up to 8 gigabits per second. It's actually gigabits. There's a little misnomer about that. If it's GB with a capital G, lowercase b, it's gigabits. And if it's with a capital B, it's gigabytes. And bits versus bytes is a subject of another video, and you know, there's gonna be a big technical video one of these days when I really geek out and explain what all these different numbers mean. But for now, we'll just take a look at the numbers and just look at it. Now it says the bandwidth current is 8 gigabytes maximum, or in bits, I'm sorry, and then you have a 32 gigabits maximum, which is exactly what they said this would have, so that's kind of cool. Of course, I don't know how you'd actually get to that. It's probably going to be driver revisions over time. You could probably do it right now, but they probably have it throttled down for a reason. And then it says over here, OS optimization. It's not supported right now because I don't have an OS on it yet. We're going to clone it over. And we can look at the performance benchmark. Now, I did play with this already. I won't lie to you. We can take a look at it again. We do have to put a volume or some kind of a folder on it to take a look at it, but it gave me a sequential read of 852 megabytes per second and a write speed of 808. Whereas the hard drive, it gave me 120 and 111. And the current HDD or SSD was 490 and 514. So it's definitely a huge improvement. And there's an option here for performance optimization. I did run this before, and if you actually look at the tests, you can look at a history here. And the Samsung drive, originally the history was it ran at 837 read speed. And after I optimized it, it bumped it up to 852. So I thought that was pretty cool how that did that just by clicking that option. There's also a thing here for over provisioning, which is kind of cool. You can actually decrease the amount of available space and the leftover space it uses as a buffer. So as this drive starts to get older and some of the memory chips start to become unreadable, I guess, or whatever happens to them, you have some other ones that it can tap into and still preserve the space. And that's pretty neat. So if you want, you can actually half the size of this and you use it just like that. After all, I am used to 120 gigabytes, but you would have a much longer lifespan on this drive, and you would also get better performance, they claim. If that's the case, you can actually use the current drive as a backup drive, and whatever you write to the faster drive would back up to the secondary drive, and that way if something goes out on you, you still have a backup of the data. The other thing I could do with the other drive is somehow I believe this motherboard or some Windows driver will allow the SSD to become a cache drive for the hard drive. So when you write stuff to the hard drive, it's actually going to the SSD first, which is much faster, and then the computer can catch up and write it to the hard drive later on, which is pretty neat. And then you can store like commonly used files in that SSD cache space, so it doesn't have to keep recalling the same hard drive space. So there's a lot of little features, which is really cool. So when you get the right hardware and you know what you're doing and you can set it up right and they all work together with each other, you can definitely get some cool configurations. Alright, so anyway, what I'm going to do now is close out of here and we're going to check out the data migration tool, which hopefully will transfer everything over. Of course, the other side of that is making sure BIOS actually sets everything up correctly. And this should be a pretty straightforward program. So we'll see. It shows obviously the picture of a hard drive and SSD coming to the Samsung drive. And the source drive is number 1 at the top, the Kingston SSD, and the target drive is the Samsung SSD. And we're just going to hit start. And it's going to say that everything on the target is going to be deleted and can't be recovered. There's nothing there, and the source disk cannot be cloned. So let's start this. Well, as we take a look at it, we're coming up to 50%, and right now it's running at 207 megabytes per second, which is pretty fast in my opinion. You know, you do hard drive transfers and you do transfers from your memory card or from your USB drive or stuff like that, and you know, you don't always get to see good speeds between those devices. Even in my network here with gigabit internet, I don't really get to see great speed sometimes because you get bottlenecked. But you know, going from a SATA drive to the PCI-E drive, both being SSD, that's a pretty good clip we're moving at. You can see it's, you know, quite a bit of data on here. I think it was just close to 30 something gigabytes if I remember correctly, but it's moving really good. And yeah, I did something the other night in this computer, just not using the new SSD, and I was surprised just alone how much quicker it seemed like it moved over the other computer. But that's because, you know, it's faster connections than I had, you know, SATA 2 versus 3. Okay, once it's done, you get this message saying that everything was successfully cloned, and then once you click OK, this pops up and saying the cloning is complete. You need to shut down and install a new disk. So we're going to hit shut down here, and then BIOS will load right back up for us. And once that does, we should be able to change the boot order and have the NVMe drive come up first. Once we get into BIOS, I want to go down to the boot menu over here and check to make sure that drive is listed, which it is. And if I click it, we should boot right into it. And that way we can test out the installation before we go too much further. And so far it seems like it's working pretty good. And now when we go in here, we should be able to go into that Samsung Magician program, and once it comes up here, it should have that drive is listed being as the main drive, and we can try the optimization. Well, it's still showing that it's not optimized because it's not supported, and maybe the drive doesn't anyway, but I figured if it was here it might. But anyway, it does have it listed as being drive C, which is perfect. And yeah, it'd be nice to have that set up. Basically, I'm going to do another video on the optimization. What you're doing is you're basically just turning off certain features in Windows, or maybe even moving certain things to another hard drive in order to increase the A, longevity, and B, performance of the SSD. One of the things is defragging. You want to make sure defragging is off, because that's going to definitely shorten the lifespan dramatically and possibly damage the drive. So it's something I already shut off because of the other drive, but we'll check it to make sure it's off. But I'm going to do a separate video on there because there's definitely some steps. If you actually Google setting up an SSD on Windows 7, there's a bunch of nice articles that came up, and basically that's what I followed. I actually read a few of them and just took the consensus between all of them and did those things. But one of the things is you actually turn off System Restore, and the reason why is because it does write quite a bit of data to the drive. And you can actually set up one of the other drives to be a restore drive, but it doesn't restore every single little thing. And since I do have backups, I'm not really worried about system restore, but that may be something to be watching if you have problems. So anyway, what I'm just going to do now is just off camera play around with some things, just make sure everything's right, maybe open up some games. All I have on here is Unreal Tournament 2004, which is definitely one of my favorite first-person shooters. But we can we can just open up something here just to see how quickly it opens. Actually, let me pick a capture the flag, or better yet, we'll do an InstaJib capture the flag, and we'll do Facing Worlds, which is one of my favorite game levels, and we'll set it to 32 bots, which is the maximum, and I'll hit spectate. And yeah, you can see how quickly that usually takes, you know, a good 30 seconds to load this level or any other level up. So it's pretty blazingly fast. And for being an older video game, it still looks very good. But as you see, everyone duke it out here as I talk. But anyway, I hope you find these computer videos interesting. You know, it's certainly nothing here is brand new and cutting edge, because simply I just really can't afford that. But you know, this just goes to show you, you can get a lot of computer for not a terrible lot of money if you do build it yourself, and of course reuse whatever parts you can. But anyway, guys, I want to thank you for watching. All I'm going to do basically from this point on is just make sure everything on this operating system as it is running fine, and I'm going to go back into that BIOS setting where I showed you earlier that we can change the boot options to having this drive be the #1 boot option. And I'll just, you know, do a couple reboots just to make sure we actually are booting into this correct version of Windows. I may even clean off the old hard drive just in case. I mean the old SSD. It's a bit of a misnomer, you know, when you're so used to saying hard drive for so long, you just tend to think of the thing that stores all your data as being a hard drive, when in fact it's no longer an actual hard drive. Anyway, I'll leave you with that final thought. Thanks for watching. We'll see you next video.